All right, so packet A, we're going to be doing some lines, some equations, and system of equations in it. So you should have all the solutions. I'm just going to go over the problems that I think will give you problems. So let's take a look at them. Right off the bat, number one, some people flip this one. It's n divided by 3. So I don't want to divide both sides by 3. The opposite of dividing by 3 is multiplying by 3. So just make sure you're doing that. And you should get negative 45 as a solution. Some people will get negative 5 there because they'll accidentally divide by 3. So just make sure that's not you. If you take a look at, here's another one that kind of gets some people. Let's deal with number 3. So it's a divided by 3 plus 10, and that's equal to 6. I'm going to subtract 10 from both sides, and I get a divided by 3 is equal to negative 4. Same thing here, I got a divided by 3. So I'm going to multiply both sides by 3, and I get a equals negative 12. So simple two-step equation, got to take care of them. The only thing that's important is the order that you do it in. 4 kind of tricks some people too, because I see this 2 equals 8 plus m divided by 11. You can't just sneak in here and say, I'm going to subtract 8 from both sides. Though typically subtraction is our first step. That minus 8 is shielded by that entire side being divided by 11. So that's actually the first thing I need to do is I need to multiply both sides by 11. And that's going to cancel that whole thing out there for me. And now I can subtract by 8. So if the whole side's divided by something, you can get rid of that in one step. 22 minus 8 is 14. I'm like 95% sure. So that's how you do number 4. Get out of here. Okay, number 6, there's just a common mistake I want to talk about in number 6. I get 31 is equal to 5n minus 4 minus 6, 1 plus 4n. Okay, so a lot of people when they do this problem, they'll do the distribution, and this is what they'll get. They'll get 5n minus 20 minus 6 plus 24n. And hopefully you are seeing the mistake by now. This negative 6, when I distribute a negative 6, that should be a minus 24n. Just super common mistake that people make. Now I want to combine like terms. I got 5 n's over here. I got negative 24 n's over there. If I put those together, that's negative 19n. And I got negative 20 and negative 6. So make sure you're keeping track of those signs in front. Some people would just put 20 minus 6 and get 14 right there. It's negative 20 and negative 6. That's negative 26. So to finish off this problem, I'm going to add 26 to both sides. And I'll get, that's 57 is equal to negative 19n. So I'm going to divide both sides by 19. And I'm going to get, divide by negative 19. And you should get negative 3 as a solution. Okay. So we had a couple of graphing problems that I wanted to do here real quick. Let me just go here. So the first graphing one was y equals 5x minus 5. So I always start with my y-intercept value. This is going to tell me where to begin. And then what I need to do is I'm going to use my slope to find all the rest of the points. So my slope in this case is 5, which I'm just going to, you can write that as 5 over 1. That means I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. Up 5, 1, 2, 3, 4, 5, and over 1, like that. So we should get a line that looks something like that, except for hopefully your line's straight. Let's take a look at 8. I get negative 7/5 x minus 2. So same thing, I start at negative 2. My slope is negative 7/5. The way that negative sign looks, some people put it with both the negative 7 and the negative 5. It only goes to one of them, right? So I like writing it negative 7 on top divided by 5. What that means is I'm going to go down 7. 1, 2, 3, 4, 5, 6. And you can see that going down 7 will put me off my graph. And I would go like over 5. So my point would be somewhere down here. If that takes you off your graph, that's no big deal. Nothing to lose sleep over. I can go the other direction. I can go up 7. 1, 2, 3, 4, 5, 6, 7 up to here. And I can go back 5. 1, 2, 3, 4, 5. And that will be what my line will look like. So even though I couldn't quite get to that point on the bottom right, I can still use my, go the other direction basically, and we should be good. Okay. So that's 7 and 8. Erase. Okay. So 9 and 10 are the reverses of those. You have to find points that work out pretty nice. So like in 9, this is just going to be a rough sketch of it. We can see right away that our y-intercept is at -2. So I know my line is going to be y equals something times x, but I'm going to have a -2 there for my y-intercept. Now I just need to find the slope. So when I'm looking at this one, I see that at 5, 1, 2, 3, 4, 5, it crosses really nice. So I just see it's up 1, 2, and over 1, 2, 3, 4, 5. So it's up 2 over 5. So it's 2/5 x minus 2. So we're just looking for good points that cross. I'll leave 10 for you to do. Remember, you have the answers, so you can check yourself to see how you did. 11, I want to write the slope-intercept form equation of the line that goes through a set of points. So I've got 3, -3. That's supposed to be a negative. That's brutal. Not much better, but whatever. So I want to write the equation line that goes through there and there. The key thing to remember is when you're doing this, I just need a value in front of x, and I need a y-intercept. If I can find those two values, I already win, right? Well, I mean, I'm done. So what I want to do first, I want to find the slope. So the way to find the slope between 2 points is I take y2 minus y1 over x2 minus x1. That just means the second y minus the first y divided by the second x minus the first x. So let's take a look at what that looks like. My second y is 5. My first y is -3. So careful, that's minus a -3. My second x is 1. My first x is 3. So what do I have? I have 5 minus a -3, which is a +8, because subtracting a negative is the same thing as addition. And I have 1 minus 3 is -2. So my slope is -4. So I know that my slope is -4. So at this point, we're halfway there. All I have to do now is find my y-intercept, and I'm ready to be done. So I can pick either point to solve for my y-intercept. So I have y equals -4x plus b. I'm going to choose this point to plug into my equation, and because it doesn't have negatives and because it doesn't really matter. This is my x value, so I'm going to plug it in for x. 5 is my y value, so I plug it in for 5. And now you can see the only unknown I have in my equation is that b value. So I get 5 is equal to -4 plus b. So I add 4 to both sides, and I figure out that b equals 9. And there's my solution. That's the equation of the line. So I'll leave 12 for you to do. And once again, you've got the answers so you can see if you're correct or not. 13. 13 is similar, but is actually easier because they did half the work for us. They want us to find the equation of a line, but they tell us that the slope is 1/2. They just don't tell us what the b value is. So we have to figure out the b value, but they tell us it goes through the point 2, 3. Well, 2 is my x value, so I'm going to plug it in for x. I don't know my b value. And 3 is my y value, so I'm going to plug in for y. So I get 3 equals, well, half of 2. Half times 2 is 1. So all I have to do is subtract 1 from both sides. And I figure out that my b value is 2. So what's the equation of my line? They gave me the slope was 1/2. And I just figured out that my y-intercept's 2. Like that. All right. So let's go back to the graph real quick. Now we're on to the systems of equations chapter. So I have two equations. I have y equals 3/2 x plus 3, and I have y equals 1/2 x minus 1. So when I have two equations, you have two lines. Wherever they cross, that's the solution to the system of equations, right? So all I have to do is graph these two lines successfully. They should cross somewhere, and I'll have my solution. So I'm going to graph this first one first. I'm going to start at 3, and my slope is 3/2. That means I'm going to go up 1, 2, 3, and right 2, 1, 2. So that's my next point. And I'm going to go in each direction like that a little bit. So that's down 3, 1, 2, 3, and back 2 like this. Down 1, 2, 3, and back 2 like that. And maybe even just go up there. What the heck? Get out of my way. Like that. So that's my first line. My second line is y equals 1/2 x minus 1. So I start at minus 1, and my slope is 1/2. So that means that I'm going to be going up 1, right 2, up 1, right 2. And I could keep going this direction, but I know my answer is not this way. So I need to continue my line this way. So I'm going to go back 1, down 2, back 1, down 2, back 1, down 2. And you can see where I crossed was this point right here. So you can write it like a point. It's -4, -3. You can say x equals -4, y equals -3. But those are the only 2 points. That's the only point. These are the only two values that make both of these equations true. So I'll leave 16 for you to work out on your own. And you know, remember once again, you have the solutions to them. Okay, so let's do one where we're solving with elimination. Let me close this down. So let's do 14. I mean 17. I saw 14 here. I'm gonna give myself a little bit of room. Okay. So the key with elimination is I want one of the variables to become eliminated. So I'm looking here at the x's. I want one of them to, well, I want them to be equal and opposite. So I see that this is positive 14. What cancels out with positive 14 is a negative 14. So what I'm thinking is, what can I multiply -7 by so that it becomes a negative 14? So if I multiply this entire bottom equation by 2, watch what I get. So my top equation is still 14x plus 10y is equal to 18. If I multiply this by -2, I get negative 14x, I get negative 16y, and I get negative 54. So when I add these two equations together, those x's are gone. And that's the whole point of elimination, is that we're able to choose some number. And that 2 came right from my imagination, right? It's not always going to be a 2. Sometimes it'll be a 3 or a 5. Sometimes you have to multiply both equations. But we just need either our x or our y's to cancel. So now that I have that done, what I'm going to do is I'm going to get the rest of the equation. I'm going to get negative 6y, and I'm going to get 18 minus 54. I'm going to get negative 36. So this is a pretty straightforward equation to solve. I just need to divide both sides by -6. And I've got half of my answer. I got y equals a positive 6. So I know that y is equal to a positive 6. That's half my solution, but I need to figure out what x is going to equal. So that's the second step of this problem. That's y equals 6 right there. So to do that, I'm going to go all the way back to the beginning of my problem. So when I'm looking at this, I see one that has all positive numbers, and I see one that has a whole bunch of negatives. So I choose the easier of the two equations. And what I do is I say, I know what y is now. I'm going to plug that in for y. So what do I get now? I get 14x plus 10 times 6 is equal to 18. So I get 14x plus 60 is equal to 18. So 18 minus 60. So 14x is equal to negative 42. So I'm going to divide both sides by 14, and we get x equals negative 3. So that's my final solution. X is negative 3, and y is 6. If you look at a problem like 18, we're going to get something weird happen, which is worth noting. I get 2x plus y is equal to 0, and negative 6x minus 3y is equal to 21. So what I want to do is I want to solve this by elimination. I look at the x's. If I could multiply this top equation by 3, I'd be in a pretty good spot. So when I do that, I have 6x, and that's what I'm looking to do. I'm trying to cancel out those x's. And I do 3 times y is 3y. And 3 times 0 is 0. But watch what happens now when I add those two equations together. I got that 6x minus 6x, that's gone. I get 3y minus 3y, that's gone. And I get 0 plus is 21. So I got 0 is equal to 21. Well, this is just blatantly not true. This is a situation where you have no solution. And that happens sometimes with lines. You can imagine if I was to graph lines that look like this, that are parallel, they'll never cross. That's what these two lines are. They're parallel lines that will never cross. So when we're trying to figure out where they cross, I get a ridiculous solution like this that won't work. So if it's anything that's not true, it's going to be no solution. So if I got 0 equals negative 6, no solution. The reverse of this is if I was to get something like this, 21 equals 21, that's when I get infinite solutions. So watch out for that. And that would be the situation where the two lines are actually the same line. So they're true not just in one spot, but in an infinite amount of spots. So let's go to so this is number 19. Now we're solving with substitution. So substitution is exactly what it sounds like. I have one equation that's solved for y. So I'm going to substitute this right side in for the y in the other problem. The point of doing this is we go from two equations that each have two variables to if I swap this out for that y, watch what that bottom equation becomes. It becomes negative 6x plus 7 times negative 7x plus 6 equals negative 13. See, it's negative 6x plus 7y, where that's the y, is equal to negative 13. So this is really the whole skeleton of the bottom equation, but I just plugged in that top equation in for y. Now I have one equation, and that one equation only has one variable, which means I can solve it. So I'm going to distribute so that's negative 55x. So if I subtract 42 from each side, I get negative 55x is equal to negative 55. So x is equal to 1. So don't stop after, sorry. x is equal to 1, like that. So don't stop right there. What you want to do is, now that we know what x is equal to, God, there's got to be a better way to erase all this at once. That was better. Now that I know that x is equal to 1, I can take either equation to solve for y. If you're looking for what y equals, go to the y equals equation. But I could do it in the other one as well. I'm just going to plug that x equals 1 in for x, and I get y equals -7 plus 6, so y is equal to -1. So that's my answer right there. And we should be good to go. Looking at 20, I have -2x plus 2y is equal to 6, and y is equal to x plus 3. So now the substitution that I'm going to be doing is on the bottom going up. So I'm going to substitute that in for y. Watch what happens when I do that, though. I'm going to rewrite the top equation. Something strange will happen, I think. If I do my distribution, I get -2x plus 2x. They cancel each other out. So all I have left is 6 times 6. 6 equals 6. That's a situation where you get infinite solutions, right? So that's going to be an infinite solution one. Okay. I'm going to help you set up the equations, the equation in 21, but you're going to solve it in the same style. So in 21, we're selling some grass, sod, and ivy. Okay, so we got Dan and Kim. So we've got Daniel's equation and we got Kim's equation. Daniel spent 126. He got 12 square feet of grass, and he got 3 pots of ivy, right? And he got that for a total of $126. Well, Kim spent $108, and she did 6 things of grass and 6 things of ivy. So this is how you set up the two equations. Lots of different ways to go to solve this one. This is going to be an elimination situation. You can multiply the top equation by -2. This will make your that I value be -6, which will obviously cancel out with the one below it. That's one good option. Or you can multiply the bottom equation by -2, because that'll make the top G 12G and the bottom G -12G. But that's basically how you set that problem up. I'll leave the solving for you, and you have the answers included, like I said, so you can check to see how you did.